Hello YouTube, RJ. Since the R10 shortwave receiver kit brought so much interest and generated a lot of comments, some of which questioned my opinion on the unit's ability to receive, I decided to build a few other shortwave receivers where we could then compare them to see which is best at receiving using a standard antenna. So we have a new kit on the bench to build. This one's also from AliExpress and it costs $32. They call it the 2020 year 5-band 3-lamp tube shortwave receiver kit with base. Yeah, I know that's a mouthful, but it's China. What do you expect? This kit did not contain any build instructions, but I was able to find these two schematics. This is a regenerative receiver, so I'll be very interested to see how well it works. It is a 3-tube radio, but only one tube does all the receiving. The other 2 tubes are used as a 2-stage audio amplifier to drive the audio speaker. Before we start the build, I want to jump over the computer and discuss how the unit works and how we're going to approach this build. I want to explain the circuit and use the chance to demonstrate the circuits as we test each section. So let's go over to the computer. Okay, here's the circuit we're working with. And let's first talk about these 2 tubes here. These 2 tubes work together as a 2-stage audio amplifier. It's pretty straightforward. They're much like a 2-stage transistor amplifier. Your signal comes in and it's coupled through a capacitor to get rid of any DC so that you only get your AC signal. This potentiometer here is your volume potentiometer. It controls your hook to ground on one side, your signals on the other, and your wiper gets hooked to this grid of this tube. So you can control how much signal gets fed through this grid. And depending on how much of the signal is fed through this grid, controls how much modulation happens of the stream of electrons in the tube. And therefore you control how much signal gets amplified. As you turn up the volume, more signal here generates more amplification. So this is your volume. So this is your first stage. As you modulate this grid, you can control the electron flow through the tube and therefore create the signal coming out at a much stronger signal. It comes out and it's fed to another coupling capacitor, which only, again, strips any potential DC that's made its way in, which you can see here we are hooked to power for biasing on these grids in the plate. So we want to prevent that from traveling in the next stage. So the audio comes through that's now amplified as a higher signal, again goes into another tube modulating the grid again on that plate, which then gives you another stage of amplification to get it up to where it can drive a speaker. Now the impedance of the tube is way off. It's a high impedance where your speakers are pretty low impedance. That's not going to effectively be able to transfer power. So they use a transformer here to change the impedance. That's the only purpose of this transformer, is to convert the low impedance of this speaker to match the high impedance of the output of this tube. And so that is the amplifier stage. Pretty straightforward. Your heaters, well, these are direct heated tubes, but your tubes are heated by a 1.5 volt battery, and the power for the tubes and amplification comes from, it says 22.5, but I don't think that's what they're using in the kit. We'll see when we get into it. Now, we understand these are just amplifiers. So where do we get our audio from our radio signal? Well, this stage here is a regenerative receiver, all with one tube. And what a regenerative receiver really is, it's an amplifier with feedback and with positive feedback. So what happens is you see 2 coils here. There's really 3 because you're going to have a coil off your antenna that interferes with these. And what happens is you have a tuned circuit here that you tune to control your frequency, to basically pick what frequencies get induced through this circuit. And as this circuit oscillates at the tuned frequency, that frequency is going to come up, it's going to modulate this grid, and therefore control the electron flow. We're going to get amplification of this weak signal. Now the interesting part about that is this tube also acts as a diode. So we get a demodulation going on, but where this becomes a regenerative receiver is while we're oscillating this, or generating, I shouldn't say oscillating, we're generating a signal here in this tube being amplified. We take some of that signal and we feed it back through another coil, and we control how much via this pot here to ground. And what we do is, by feeding some of the signal back in and inducing it back in here in phase, positive feedback, we create a massive amplification increase in this tube, where this tube, maybe this tube could do say 10 to 1 amplification. It's possible to get in some circuits, they were getting up to 2,000 times amplification because of the positive feedback. And how much is controlled here? Well, as you do this feedback, an amplifier, you know, the old joke used to be, how do you make an oscillator? Try to make an amplifier, because amplifiers love to break into oscillation. And so by feeding feedback in here, we create oscillation in this tube, and you control it here, or we can, let's put it that way, can trigger an oscillation. And depending on the mode that we're receiving, varying this will control whether this oscillates or not, and help us pull out and demodulate signals better or worse. So you play with this, and you'll see as we play with this receiver, you'll play with this to clear up your reception. Your RF's coming in, being induced in here. This is being fed back in, running through the tube. So since you get so much amplification now, we get a signal out here that is very little of any other signal but our tuned signal, because non-tuned signals didn't get amplified, brought through the circuit. So we end up with audio. So as you come over here, we hit our amplifier circuits, we drop all the DC, we come in as just pure audio, only the positive side. We've done some rectification here. And so that's what's driving our audio section. Now, hopefully I didn't mess that up too bad, didn't confuse people. It's not the easiest thing to explain. I didn't want to get into too great a detail, so I simplified a few things. But for the most part, that basic explains how the regenerative receivers work. Now, why don't we use these? They're very simple, need very little parts. Well, there's some cons with this system. One is, when you break this tube into oscillation to receive, say, SSB or CW, you're directly connected to your antenna, so you actually transmit a signal out. So this thing has a habit of becoming a transmitter, and that was kind of a problem because you were basically jamming other receivers. So that there was ways around it, but that kind of was one of the big problems, was spurious emissions using it. There was additional, you had to play with the regen control anytime you changed frequencies to another station. You know, that was a little problematic since, you know, everybody wanted a one knob, turn the knob, tune in your station, and you were done. The reason this was created was tubes cost a lot of money back then, and they were trying to build the least amount of tubes in a radio they could. In fact, they had some of these that had one tube. It had other stages do amplification. You know, this allowed them to build a really cheap radio. These expensive tube things, they didn't have a bunch. But these things came down in cost dramatically. And so pretty soon, you know, the super hets and stuff came in where having a bunch of tubes didn't matter. You had a much better receiver with the super het. Selectivity, sensitivity was much better. Therefore, these went away. Nowadays, it's just an interesting circuit to play with if you're interested in radio circuits like we are. Let's try building these audio circuits, make sure the audio stages, and make sure they work right. If they do, then we'll jump on our regenerative receiver stage and see if we can get that to work. We're going back to the bench. See you over there. Okay, let's get started on building our kit. Let's get some of this extraneous stuff we don't need right at the moment out of the way. Right off the bat, one of the little pieces for the wire guide on this transformer broke as soon as I touched it. This is cracked and fixing to come off too. Yeah. Luckily, we're not needing that wire guide at all, so I'll just throw that in the garbage. Okay. We got our circuit board. The first thing to note is your loose parts aren't loose. They've put them in the board. I'm not sure if that's because they just didn't want to write instructions and thought this solved a problem. Probably they got some bad reviews for not having directions. They've bent them all over real heavily, so that's a mess. I guess we can straighten up these leads, trim some of them off a little. It's the first time I ever had a kit like this. I've never had a kit where parts were already put in and done like this. I expected they'd be in a bag like our last build. So anyway, it was all just saran wrapped. The only thing you've missed, I did videotape me taking the saran wrap off of all of this because I thought it was a complete waste of time to do that. My videos tend to run too long anyway. So I'll go ahead and get all these straightened out and I'll be back. Okay, all I did was trim off these, get them a little tighter, a little more lined up. My plan was to put parts on for just the one stage of the amplifiers and then test it. But being the parts already put all in, I'm going to go ahead and solder them in. And then I'll just inject signal into one stage at a time and test. So let's first get these loose components that we're putting the board in. So I'll solder this up. Imagine I'll probably time lapse this for you so you don't have to sit and watch me do the whole thing. Be back with you in just a minute. All right, we've got those parts soldered and we have trimmed them off. That was pretty quick, pretty straightforward. Then putting the parts through the board kind of sped things up. The board layout's not the best. The resistors don't really have the distance. They had to fold the legs to get them in. It's almost like they were made for smaller resistors, but they didn't provide those. So you can probably make out there, like this resistor right here, when they put it through the board, they folded the leg. Well, they did that because they didn't have room to really get it in there. So not sure what's going on there, but that's part of it. So the next stage is going to be to, and I'm making this up as I go simply because we have no instructions, is probably to put the sockets in, would be my guess. I believe they're going to be probably the next tallest items. So let me see what we have here. Are they all the same? I mean, they all look the same. Yep, they all seem to fit equally well. Let's go ahead and put our amplifier sockets in. We'll just start with those. Or I guess I could just do all three of them and not populate the regenerative one yet. See if I can get this flipped over with them being held in for me. Now these rascals are going to be a little bigger, so how well they're going to solder. But I think I'm going to go to my bigger solder for these. So I'm going to hold the board down tight against them, and I'm going to go ahead and solder one of them in. Okay. And once we get this one soldered in, okay, now I'm going to go ahead and solder all that in, but I'm going to use the extraction fan to get smoke out of my face and keep me from breathing that toxic stuff. So you're going to have to bear with me. I'll time lapse that too. Okay, with that, our sockets are all soldered in. They look just marvelous. And we're ready to move on. What do we need to do at this point? Kind of flying blind here, but should we put in power switch? Do we have a marking here for which way it goes in? We have an indicator on the board for one, but I'm trying to find a marking on the switch for one. I don't see a marking for first position on the switch. Fits tight. Let me try turning it around. I think the label This side has a label that says on off. I would think that would go out, but with the limited information we have to work with, I'm just going to have to go with that and hope that it's correct. So let me get a little solder on these. Not real happy how that's going down. I think I'm going to put a little flux and give it another try. See if that helps a little. Okay, happier with that. So that's installed for us. So I'm going to say the next thing we probably ought to put in is these. Well, looks like what we're going to need to do, rig up our power, which is going to go in these connections right here on the circuit board. And I've got to try to make sure I understand it. Okay, that's in, and that's the 1.5 that's going to heat the tubes. Big problem I'm running into, or not running into, but questioning is everything I could find talks about this thing being higher voltage than 9 volts, but they gave you a 9-volt clip. And down here it talks about 18 to 90 on the board. On the plans it says 22.5. So what I'm thinking is maybe like doubling batteries here. Maybe put a set of 9 series. I mean, I know they sent this, but we're not anywhere near the voltage anything says we should be operating at. How about I build it the way they want it built, and then if we don't like the outcome, we'll try increasing the voltage. I mean, does that sound reasonable? I mean, obviously this is what they were intending. I don't know if they were just so cheap they didn't want to give you two 9-volt clips. I have some. We could definitely put on there, but see if I can get these to stay in long enough to get soldered. We'll try it their way first. You would think that, they know how it works. We'll try their way. If it doesn't work, we'll turn around and increase the voltage. They might have changed some resistors or something that. Okay, so we've got power in our kit now. I guess the next thing we need to think about is putting some pots in, probably. See what we've got here. B1M, that'll be your 1 meg. B100K. Interesting. This says 10K, but this is a 100K pot. What's the schematic says? Schematic says 10K. This is not a 10K pot, I don't think. I think this is 100K. Let's kick on the LCR beater and find out. This is definitely 100K. So why do I have 1 meg? Verify this. And 100K with everything's, the board and everything is 10K. That is definitely 1 meg. I don't know. I mean, I've got other pots. I could change it out, but I don't know whether I should go with what they sent me. Definitely says 10K here. Interesting enough, says 500K here. So the volume, they gave me a 1 meg. The board is marked 1 meg. Here it's 500K. What's it on the other plan? It shows. This plan says 1 meg. This pot says 1K. This pot says 10K. 10K. And they gave me 100K. You know, the part's 10 times what the board calls for. The board is 10 times what the plans calls for. At least one of them. The board and this plan agree. I'm not sure. Let me grab a 10K out. There's only two things, one resistance that goes up 2 times, and that's 10K. Let me pull a 10K pot out. Give me a minute to go get my pots. See if I can't get me a 10K pot. I'll be right back. Okay, let's see what we can find. We want a B10K. Here we go. Because that's a B100K they sent. Linear. So, I mean, are we going to be able to make this work? We're going to straighten some legs. See if they'll straighten without bending. Or, I'm sorry, straighten without breaking. Okay, let's set the 100K out of the way. We're going to put a 10K in there and hope that's correct. And the 1 meg, we're going to straighten this leg right here. We're going to get him in. I think I'm going to do one at a time. Tack one leg down. Like that. We'll take this and heat it up. And I'll stand her up to where I feel like she's straight. Alright, that looks pretty good. Let's get some other legs soldered. Little fan action. And we'll go ahead and put this one in. I think we're going to call that for tonight. This is going to be a long enough video, easily long enough. So we'll get this pot in, we'll call it an evening. We'll pick back up in the next video. We'll go and finish building this thing and see if it works. I'm just going to get this pot put in. Okay, with that, we're going to close out this video. We'll pick up in the next video. We'll continue on building this thing and get it finished. We'll check these audio stages. We'll go ahead and finish building this thing out. We'll give it a test and see how it does. Hey, thanks for hanging out with me in the video. Hopefully you'll catch me in the next one. Make sure to click that subscribe button if you haven't. Hit the like button if you will. And hit the little bell if you want to be notified when I do another video. Thanks a lot.